One, vertex. Okay, you haven't had to find the vertex yet of a graph, so that's new. Number two, x-intercepts. Have we found x-intercepts before?
Yes.
Yes. Number three, max and min. Have we found max or mins in this class before?
No.
No, so that's new. Number four, domain. Have we found that?
Yes.
Yes. Number five is axis symmetry. We're going to treat axis symmetry. We're going to cross that off on every one because we're going to talk about axis symmetry a little bit later in another section. We're doing reflections and all that fun stuff. So whenever it says axis, you can cross it off. The fifth one is y-intercept. Have we talked about y-intercepts before?
Yeah.
Yes. Next one is value, which is your max and min value. That's new. The last one is range. So that's new. So really we got three things to talk about that we haven't done before. Other than that, they're all repeats of what we've already done. We're just making them expand a little bit broader on what we're going to do. All right. So we're going to look at number two first of all. So you come to your gravity calculator. You go to y equals. I'm going to clear this, and we're going to put that in there. So that's x squared plus 2x plus 1. Then I hit my graph. Okay, that's what everybody's graph should look like. Okay, that's what everybody's graph should look like. Now, the vertex, I'm going to show you another way to find the vertex because the vertex is a refraction, and when you trace on your calculator, it never gives you the exact value. It always gives you like a round. So what we're going to do is I'm going to show you exactly how to find the vertex on your calculator. Okay, the information that we can find on our calculator here though, let's go over that right now. First of all, x-intercept. When we are solving for the x-intercept without using the calculator, just by doing it mathematically, what do we know about the x-intercepts?
When y equals 0.
Okay, the x-intercept, the y value is always 0. So we go to our graph on our table on our calculator. It's second graph. Okay, so if we know that if I'm looking for the x-intercept, I'm looking for my y value to be 0. I go to my table and right there, my y value is 0, so my x-intercept is -1. But remember, for your x-intercept, you don't put -1 because the x-intercept is a what? It's a point, and so you have to write down the ordered pair. So your ordered pair would be -1, 0. All right? Now, if we go back to our graph, how many x-intercepts do I need to look for?
2, 1.
Only one this time because the graph only touches x-axis one time. If it would cross the x-axis, for example, one here and then down here, you'd know you'd have two x-intercepts, so you have to look for two different spots where your y value is 0. Okay? So now let's go to my next thing, y-intercept. My y-intercept. How many times does it cross the y-axis? Once. What value do you know if you're looking for the y-intercept? Your x value is 0, so I go to my table. I've got to look where my x is 0. There it is. So my y-intercept is at the value
1.
0, 1. Again, it's a order pair, so you have to put down the order pair. All right. Now the domain. We get that from our graph. And when you have your sketches, I expect you to spend maybe 5 seconds on your graph. Quick sketch of what it looks like. You don't need to get exact points. Quick sketch and just sketch it, okay? Let's look at the domain. We've already talked about domain a lot in here. So we look at our graph. As this gets higher and higher on the left side, how far does it go out on the x-axis? It goes forever and ever, right? If it goes higher and higher on the right side, it goes how far on to the positive numbers?
Forever.
Forever. So you can write down one of two things. You can write down all reals, or you can write down what? Negative infinity to positive infinity, and you got to put it in interval notation.
That's for domain.
That's for our domain, right? It's for our domain. Now, the next thing we can find on our calculator is the range. If I look at my graph by range, what's my smallest value of my y values? 0. So my range is going to be 0, and it goes to what? Positive infinity. Parentheses. Every time you do domain and range, if you use all reals, perfectly fine. Do not use greater than, less than signs anymore. You only use interval notations if you're not using all real signs. You hear what I'm saying? If you use greater than or less than signs, I'm going to take off. Yes?
I don't see why it's 0 negative. Like, I see the negative.
What's my smallest value on the y-axis?
Like 0.
It doesn't touch until it gets the y is 0, and then it goes positive infinity forever and ever.
Okay.
Okay, because you're only looking at the y values, you're not looking at the x values. Right?
But it looks like it's crossing the y on like, I guess. It'd be 0.
When y is 0, you have your first x value, and you know that because it's your vertex. That's your starting
Oh,
point.
okay,
Right?
right,
Okay, alright. Now remember, the only time your domain will not be all reals is when your variable is
not a,
what?
when it's flipped, right?
Underneath the radical.
When your variable is underneath the radical, or your variable is in the denominator of your fraction. If you don't have those two situations, you always have all reals. Okay, you always have all reals. Alright, so those are the things we get directly from the calculator. Okay, things we can't get from the calculator. First of all, your vertex. Okay, remember my main equation was y equals x squared plus 2x plus 1. To find your vertex, again, the vertex is always your starting point of your parabola, right? So that's, if it's a starting point, we represent that with as a what? Order pair. So if it's an order pair, it's got to be a parentheses x value, y value, right? So you need x value and y value. Okay? My x value of your vertex is always negative b divided by 2a. Star that. That will be on your test. You must memorize it. I'm not going to give it to you. I'm telling you 100% though. There are going to be questions on your test where you have to do nothing else but find the vertex. And it will not be where you look on your calculator. It's going to be a fraction part. So you have to know that equation. I'm not going to give it to you. There will be a bunch of you come to the test and say, oh, I remember you telling me to memorize it, but I don't know it. You're going to miss it. And if you're finding the vertex, that's going to be 2 checks because you have to have an x value and a y value. Alright, so if this is the case, what's my b value in my equation up here?
2.
My b value is 2, and what's my a value?
1.
1. So if I come down here, x is going to equal a negative 2 divided by 2. So x is actually equal a negative 1. So my x value is actually a negative 1. That's my x value of my vertex. Okay? If I know my x value, how do I go about finding my y value then?
Plug it in.
Just plug it in. You plug it in. Or you could do what? You could go to the table. But if it's a fraction, it won't show up on your table. Because only whole numbers show up in your tables. So, we just plug it in. Negative 1. What's negative 1 squared? 1. What's negative 1 times 2?
Negative 2.
And then plus 1. So I got 1 minus 2 was negative 1. Negative 1 plus 1 is?
0.
So my vertex is 1, 0.
Negative, sorry.
Negative 1, 0. My vertex is negative 1, 0.
Now, will it always be the same as your intercept?
No. No.
It was just coincidence.
Just coincidence, sir. Okay? Alright, now, let's look at a graph here first of all. Let's go to max and min. Okay? Anytime that your parabola opens up, and I don't care what it looks like, anytime your parabola opens up, you're going to have a minimum value. A min. Anytime. Anytime your parabola opens up, you will have a minimum. So therefore, if your parabola opens down, you're going to have a what?
Max.
A max value. So you go back to this graph here, do you have a minimum or a maximum? You have a minimum because it opens up. So in your worksheet right there, you put min. Okay, you put min, yes.
So is that saying that your vertex is your minimum value?
Okay, we're going to get that. Okay. So that's going to tell you if it's a min or max. So we look at this, we say, okay, I definitely have a min. Okay? Now, right across from the min or max, it says the value. They want the exact value of your min or your max. Okay? Your min slash max is always the y value of your vertex. So if you screw up your vertex, you've already missed your value as well. Encouraging words to hear. Right? So if I screw up this, I've already got this wrong too. Great. Good job. Okay? Words of encouragement. I always like to brighten your days just a little bit more.
Thanks.
Okay, right, so make sure your vertex is correct. Okay, but your min and max is always the value of the y value of your vertex. Always, always, always. Okay, your min and max is always the y value of your vertex. Alright? Alright, let's do number 6 together as a group. Okay, turn your worksheet to 6. We'll clear this. And the way I do squared,
Minus 4x.
minus 4x,
What,
minus
minus 5?
5.
Yeah.
Okay, I graph it. I look at that, I say, okay, so my graph is going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, between negative 4 and negative 5, and a little bit over. So I got a negative 1, 2, 3, 4, and it's a little bit over, and it goes down, roughly like that, okay. Okay, it looks like that, okay? So, first of all, the vertex. I gotta come back from my vertex. So I say, okay, I know that x equals a negative b divided by 2a. Well, I look at my worksheet, I say, okay, my b value is what? Negative 4. So that means my top number is going to be 4. Because a negative of a negative makes a positive. If I put a negative 4 in for b and I got a negative out front, negative and negative always makes it positive. Divided by 2a. My a value is what? Negative 6. So 2 times negative 6 is negative 12. So my x value reduces down to what? Negative 1/3. Negative 1/3, right? So I know my x value is a negative 1/3. Okay? Now to find my y value, I know it's a fraction, so it's going to be kind of hard. So we'll just write it out. If I look at my equation, then I just write it like this. Say, okay, a negative 6, parenthesis, what's 1/3 squared?
Negative 0.11.
No. Just let's think about that. Negative 1/3 times negative 1/3 is a positive 1/9. Okay, before you put this in your calculator, write this out. Okay, then I got minus 4, parenthesis, negative 1/3, minus 5. Now with all your calculators, now all you got to do is put it in exactly the way we wrote it. Negative 6, parenthesis, 1 divided by 9, parenthesis, minus 4, parenthesis, negative 1 divided by 3, parenthesis, minus 5, enter. You don't have to worry about any kind of order. What do you get? Nope.
Negative 13 over 3.
Negative 13 over 3. Negative 13 over 3. Make sure everybody does that properly. If you do it the way that I wrote it here in the exact order, you cannot miss it. That's why I would go back if I was you. I'd write it out and then put it in your calculator. So many of you just punch in your calculator, we mess up because we make a small mistake. Okay? Negative 6, parenthesis, 1 divided by 9, parenthesis, minus 4, parenthesis, negative 1 divided by 3, parenthesis, minus 5, enter. That gives you a decimal number. Math, enter. Got it. Did everybody get negative 13 over 3? Did everybody get that? Kai, did you get it second time, son?
Yeah.
Okay.
That's the vertex, right?
That is your vertex. Okay, so we got our vertex. Our vertex right now is negative 1/3, negative 13/3. Alright, my x-intercept. Look at my graph. How many times does my graph touch the x-intercept or x-axis?
No.
0.
None. So you put none, and you can tell because it doesn't touch the x-intercept. None. Pretty easy. Max or min? Is that a max or a min?
It's max.
It's a max. We know it's a max because it's going down. So right away we can plug in my value. My value is always what? The y value of your vertex. So it's going to be the value of negative 13 over 3. Negative 13 over 3. Alright, let's look at our domain. We go back to our graph. We look at our domain. Okay? As this goes down forever and ever and ever and ever and ever, it will go what? All the way to infinity. As this goes down forever and ever and ever and ever, it's going to go positive infinity. Also, if you look at your equation, are your variables underneath the radical? No. Are they in the bottom of your fraction? Nope, so your domain is?
Oh, no, number